Hello everyone. Welcome back to another lecture. Today we will learn about some fundamental laws that govern electric circuits. Specifically Ohm's law and Kirchhoff law. We will start with Ohm's law. Materials generally have the ability to resist the flow of electric charge. To be more specific, they can resist current to a degree. The ability is known as resistance. It is measured in ohms. To find the resistance of these materials, we make use of this formula where ρ is resistivity measured in ohm meter, L is the length measured in meters, and A is the cross-sectional area measured in meters square. For extra information, good conductors have low resistivity while insulators have high resistivity. The circuit element used to model resistance is a resistor. It looks like this in a circuit diagram. The relationship between current and voltage for a resistor is known as Ohm's law. Ohm's law states that the voltage V across the resistor is directly proportional to the current following through the resistor. Resistance is the constant of proportionality. This leads to the final equation for Ohm's law being voltage equals current times resistance. The value of resistance ranges from 0 to infinity. The left diagram represents the resistance as 0 or approaching 0. This is known as a short circuit. The right diagram represents the resistance as infinity or approaching infinity. This is known as an open circuit. Some information about resistance. Not all resistors follow Ohm's law. Those that do are called linear resistors. A linear resistor has a constant resistance. Non-linear resistors like light bulbs and diodes do not obey Ohm's law. The resistance varies with current. Conductance is the ability of an element to conduct electric current. It is the reciprocal of resistance and it is measured in mhos or Siemens. Here's an example. We will make use of what we just learned to solve it. Calculate the current, conductance and power of the resistor. Pause it and try to do it. To explain, the same current flows throughout the single-loop circuit. Use the Ohm's law formula to find the current and the conductance formula to find conductance. Find the power using the power formula and the current you found. All elements in a circuit can be rearranged in different ways. This is circuit topology. All circuit diagrams have branches, nodes, and loops. A branch represents a single element. A node is the point of connection between two or more branches. A loop is a closed path in a circuit. In this circuit diagram, we will find the number of branches, nodes, and loops. There are 3 resistors and 1 voltage source, meaning they are 4 elements in the circuit. So they are 4 branches. All the letters you see in the circuit represent nodes. They appear before or after a circuit element. Note that if the element between 2 nodes is short-circuited, aka no element between them, the 2 nodes are the same. The figure has 3 nodes. Node A, B and C. The circuit as seen has 2 closed loops. Another thing to know is that a loop can be independent, meaning it has at least one branch which is not a part of any other independent loop. This results in creating a set of equations that will be discussed later. Loop ACCB or BCCB can be considered as an independent loop. Not both at the same time because they share a resistor element. A circuit with B branches, L loops and N nodes follow this fundamental theorem. Number of loops plus number of nodes minus 1 equals the number of branches. In a circuit, elements can be connected in series or parallel. 2 elements are in series if they share a node. They will carry the same current. In the previous circuit, the voltage source and resistor 1 are in series because they share node A. 2 elements are in parallel if they are connected to the same 2 nodes. They will have the same voltage across them. Resistor 2 and resistor 3 are in parallel because they are connected to node B and C. Here's another example. How many branches, nodes, and loops are on the circuit? Identify the elements in series and parallel. Try pausing it and figure it out. Here's an explanation. They are 3 closed loops. There are 5 elements, meaning there are 5 branches. Before and after each element is a node. So put letters to it to make it easier. But remember, if there are no elements between any 2 nodes, those nodes are equal. Check your highest letter to see the number of nodes. In the circuit here, they are 3 nodes. Clarify your answer using the number of branches formula. To find which elements that are in parallel, find 2 or more elements that are connected to the same 2 nodes. There are 2 sets of elements in parallel. The 1 ohm and 2 ohms resistors are in parallel and are connected to node B and C. The 4 ohm resistor and 10 volt source are in parallel and are connected to node A and C. Since we are only looking at the base circuit, no elements are in series. When we get to resistor manipulation, that will be a different story. Moving on. Kirchhoff's laws help in circuit analysis. There are 2 of them, Kirchhoff current and voltage law. Kirchhoff current law states that current entering a node is 0. In the equation, n equals number of branches and n equals the current entering or leaving the node due to that particular branch. Current entering a node equals current leaving a node. The first diagram shows nodes A and B. We see that there are 2 currents leaving node A and 2 current entering node A. Using the law, we see the equation of the currents around node A. Kirchhoff voltage law states that the sum of voltage of each element in a loop is 0. In the equation, M equals number of voltages in a loop and Vm equals the voltage of an element. In the figure, the voltage around the loop is as shown. Remember that signs and polarity play a part in the equation construction. See how only V1 will be negative if we use a clockwise loop. Last example. Find V0 and I0. It might look difficult to some, but all you need is to find a first step. Then take it step by step. Once you analyze the circuit, think about it, then write out equations based on the laws you just learnt. The equations will start to relate to each other, allowing you to find the solution. Pause it and try and figure it out. There are 3 loops, 4 branches, 1 dependent source, 1 independent source and 2 nodes. Using KCL at node A, we get this equation. Since all the elements in the circuit are parallel, all the elements have the same voltage. Using, we will find the KVL equation for loop 1 and simplify. At the end we will get a variable for V0. We will use that on the 8 ohms resistor to find its current. After finding the current of the 8 ohms resistor, use it to find I0 with the KCL equation. Go back to the KVL equation and find V0 using I0. At the end, I0 equals 4 amps and V0 equals 8 volts. That will be all for now. Thank you all for your time. Till next time.